Welcome to this video on AI-based cognitive research on textual documents through vector embeddings technology. In the previous video, we talked about how a large language model works. In this video, we will discuss the introduction of the topic of AI-based cognitive content vectorization. And in the videos that follow this one, we will talk about the new ways of searching and visualizing data that come from this technology. Let's start with an introduction to the topic of vectorization and embeddings. What does vectorization of text mean? And what advantages does it give us in searches? AI-based vectorization is a way to transform text into a series of numbers represented by a mathematical vector. Imagine having 3 sentences. My cat has 2 beautiful eyes. My dog is a short-haired Labrador. My bike has 15 transmission gears. Through a large language model, it is possible to do embeddings, to transform into a mathematical vector some texts. And the calculated mathematical vector can be inserted into a new type of database, a vector database where it will be possible to save text and its related mathematical vectors. Vector databases are very powerful tools and able to work with millions of records very quickly. What is a vector search? And why a vector search always begins with the description of a context. If you wanted to search for content in your vector database, which I remind you only contains the 3 phrases we previously indicated, the first thing to do is define the search context. In this case, we will use the context a blue purring kitty. At this point, we can ask the vectorization and embedding engine to calculate the mathematical vector of that context. That vector will then be used to search the vector database. The search to be conducted on the database will aim to calculate which mathematical vector, among those present in it, is closest to the concept indicated in the context. This distance is called vector distance. This shows us that the concept of kitty is close to the concept of cat. What is absolutely new in all this? Now it is possible to do new types of searches. And the most important thing is that it is possible to do searches of concepts and not just searches based on the presence of keywords in the text. Therefore, you can search for the presence of a kitty, even if in your knowledge base you only have phrases that talk about cats. Let's try to better understand how a vector search works. Imagine your knowledge base being vectorized with vectors that have only 2 dimensions: empathy and living being. Now we represent in this 2-dimensional space the concepts of cat, dog, and bicycle. The result? We find that the dog and the cat seem to have been put close together because they are both empathetic living beings, while the bicycle stands far away because it is neither a living being nor empathetic. It almost seems like AI has really understood the deep meaning of those concepts. We will see soon that it is not quite so. To understand the novelty brought by this search technology, if you query a traditional database containing dog, cat, and bicycle using the keyword kitty, you will not get any result. But using vector search, it is possible to perform a search for concepts, looking for those with the closest cognitive meaning, even if the concept to be searched has been described with different words. How was it possible? Did AI really understand that dog, cat, and kitty are living beings and that kitty means young cat? Let's see how this technology works. To questions about whether AI has become sentient, understanding the true meaning of things, recognizing the nature of things, we can clearly say no. At least not for now. Okay, but how does it then understand the similarities between concepts? It all depends on how the large language models were trained. All the available human knowledge online has been collected and special databases have been provided, months of training have been served, and finally the first large language model was born. Large language models have shown to be able to do 2 things. First use case. From a question to an answer. Second use case. From a concept to a mathematical vector. And, by the way, there are many large language models on the market, starting from the first one created in 2019 up to today. There are many of them. Basically, they all work in a similar way. but with different performances. Therefore, if vector searches are performing so well, this is due to how large language models were trained. Indeed, during the training phase, dog and cat were always found close to statistically similar cognitive concepts. In these contexts, dog and cat were found close to words like kibble, fur, forelegs, mustache, eyes, leash, bowl, cuddles, and many more. While the concept of a bicycle was found in cognitive concepts very different from dog and cat. In these contexts, words such as gearbox, handlebars, saddle, spokes, wheels, gears, brakes, and many more were instead present. The reason why the concepts of dog, cat, and bicycle still have something in common and therefore are in a relationship of distant vectorial proximity is due to the fact that all those concepts also have some words in common. And here we finally come to the point. The reason why the concept of kitty is recognized as close to dog and cat is because it was found in similar cognitive concepts, where the same words were used from a statistical point of view. Now we understand why those cognitive elements are graphically represented by mathematical vectors in close positions to each other. This is due to the fact that they are part of different cognitive clusters, where the words that make up each cluster are homogeneous among themselves, but in the whole system there are also some words that describe concepts in common between the various clusters. And this is the reason why all the concepts, with various vector rankings, are connected to each other. Through embedding, mathematical vectors are calculated on the concepts present in a knowledge base. This allows to define the vector ranking of each concept and understand the mathematical distance existing between each vectorized concept inside the knowledge base. From this derives the possibility of exposing each concept according to its own vector ranking. For this we understand that kitty is closer to cat than to dog. Thank you for watching this video. All the functions that have been described in this video are available in our application BoK, Branches of Knowledge. To request a demo, click on the below link.